I'm so glad to see you here. I know it's really tempting. You see your kid and you love them so much and they work so hard and they're so cute and you want to be like, hi. And I'm going to actually ask you not to do that until you hear a very magical word. What is that magical word?
Sing!
Fourthitos, why is that so important to wait for that moment? What will happen? Grace?
Because you'll probably get distracted.
Yeah, we'll get distracted and space out. You gotta concentrate. What else? What else, Miley?
Because you may be like staring into your parents' eyes and be like,
Yes, another good reason. And so we'll just ask you to hold that moment.
yeah, guys.
We also take drama here at Manzanita, and we learn a really important thing, which is audience etiquette, which means I will say action, everything in between is the play, and then at the end, together, they will say scene. And in between the words action and scene, we ask that if you find something funny, you laugh. If you're invited to participate, please do, but otherwise, please keep your conversations until after that magical, magical word. I hope you noticed some of our geological wonders in row 1. Fossils here from the Santa Monica Mountains, metamorphic rocks, because we know that this used to be volcanic. And some of the big ideas we studied, Axel, take it off, were the idea that the Earth is made up of living systems and itself a living system, and that everything is alive on this planet, even the things that we sometimes think of as non-living. And that everything is related to each other. And so I'm curious if at the end you agree that we showed that message. We decided to tell the Earth story as a fairy tale. And yesterday afternoon it was like, woo, this is amazing. But then, a very loved member of our community, Saluna, got sick. And so I just want us to all take a moment to think of her and send her loving energy. She worked so hard on this. She cared so much. She had a really big part. So we came back this morning and we talked about one of our favorite symbols, the axolotl, and how resilient it is, and how when you cut off one of their arms or their gills, it grows back, and how we were going to do the same. And we redid the whole POU. And then another deeply loved member of our community got sick and went home. And then we had to do it all again. And that is a testament to how resilient they are. Can we just show them some love? And so it might not flow or transition or make sense as it once did, because we had to cut things. And we're just going to show a lot of love and grace for that. And let's all take a moment to send some of our community love and magic to Nova and Saluna and Eli, who's on vacation. And we wish they were here. But like the axolotls, we are resilient and we are capable, and we have an amazing story to share with you. The story of our Earth. Places. Everybody take a deep breath in. Let it out. Find your grounded energy. Take a moment to look at this beautiful land we're all a part of and that we've been learning. And action. Once upon a time, about 4.5 billion years ago,
That's 4,500 million years ago.
a star went supernova, which means it got so big, it exploded! All matter in our solar system came from and dust from the dying star swirled around and created a solar nebula. Over a long period of time, the gases and stardust condensed, and they pulled in more and more matter with gravity.
Yo, I'm gravity. Let's make a planet time. Yeah. Don't be a wuss, bruh.
The gases and stardust condensed until they pulled in more and more matter with gravity. The more gravity pulled in matter, the stronger the force of gravity became.
Yeah, go gravity.
Thanks to time, gravity, and pressure, the stardust condensed into a mass that became our Earth.
We're baby Earth.
But the baby Earth was a hot mass of magma. It took a long time for the Earth to cool and form layers.
The layer that we're standing on right now is called the crust. You might think that the Earth is just a solid ball, but it's not. There are 4 layers. Think of it as an onion. You peel back one layer, there's another. Peel back that layer, and there's another, and so on till the center of the Earth, the inner core. That's me. And now the crust. So, okay, the first thing we're going to be doing is revenge! Okay, one fact about me is I'm the thinnest layer of all the layers. And I'm made of soil, water, and rock. Ha! This rock is a sedimentary rock because it's so weak. Thank you, crust. And now the second layer of the Earth, the mantle. Hi, I'm Mantle. If you peel back the crust layer, you will find me. The mantle, the crust floats on the mantle. The mantle is made out of a hot substance that is half liquid and half solid. That liquid is called magma. That substance is called magma. The mantle is the thickest layer of the Earth. The third and fourth layer of the Earth is the inner and outer core. Hi, I'm the inner and outer core. These 2 layers are the hottest of all 4. Thank you. Ignore her. The outer core is liquid metal of mostly nickel and iron, and the inner core is a hot, dense ball of mostly iron. And that's all I have. Cannonball! Let me check the schedule. Yes, I have to introduce a very important star brother, and that very important star brother is gravity. Hi, I'm gravity, and I keep the place from flying off into space. If you're so mature, why are they flying off into space right now? Oh, I'm Pressure, his sister. Okay, you keep the planets from floating off into space while I heat the inner core and outer core. Okay. Oh, did somebody say my name? Time, you're in the wrong scene. Oh, sorry about that. Come back! Once upon a time, a long, long time ago, paleontologists discovered 2 of the same exact fossils in South America and Africa. I found a fossil. I did too. Want to see mine? Yeah. Whee. Wow, do you want to see mine? Sure. Wait, they look the same. Well, you see, South America and Africa are like thousands of miles apart, so people wondered how this was possible. Until this guy called Star Brother Alfred Wegener came along. Hi, I'm Alfred Wegener. I developed the theory of continental drift. Now I'm going to explain to you what continental drift is. Continental drift is once all the continents were together in one continent named Pangea. And you guys might be wondering how this happened. Well, it's because of tectonic plates. Tectonic plates are plates that float over the mantle. And because of the tectonic plates moving away from each other, the continents moved away from each other. Don't go, Star Sister South America. Don't go, Star Brother Africa. Bye, guys. I have to go make Australia. Bye, guys. Gotta go be cool in Antarctica.
Today we're going to be talking about tectonic plates. No, not plates that you eat from. Plates in the Earth's crust.
Pizza!
No, long period of time. This is old Grandpa's time, and he's going to speed this process up.
I'm tired. I speed this up.
And this type of tectonic plate can make mountains and volcanoes.
Transform boundaries are when two tectonic plates slide past each other and create earthquakes. Now let's go check on the dinosaurs. They're experiencing a major earthquake right now. Hi, this is Dino Dan. We're waiting for Dino Land. Let's check on Dino Dano.
I'm Dino Dana, and we're all going to die. We're going to die.
Meteor! Divergent boundaries are when two plates slide away from each other over a long period of time.
Oh, it's me time. I'm going to speed this process up. There we go. There we go.
They can create massive ocean trenches, volcanic eruptions, and sinkholes.
Oh, I'm going to walk on this little trail. Ah, Grandma!
The Earth is a living system.
The Earth is a living system because of the four spheres that shape it together. These spheres are always connected and always living. These spheres are
The geosphere,
the atmosphere, the hydrosphere, and the biosphere. Speaking of biosphere, let's walk into some examples of what a biosphere is. Look, I'm answering you. This is a perfect example. And a monkey.
monkey,
And a red-tailed hawk. Even humans are part of the biosphere.
Hi,
biosphere.
Hi.
All of these examples need water to survive, so let's dive into the hydrosphere.
Although the hydrosphere is all water on Earth, and all water on Earth through the water cycle is the same water since the beginning of time. We drink dino pee.
Yes! I remember having a hot dog. That's also dino pee.
That just happens through the water cycle. Now I'm going to show you an example.
The water cycle is when rain rains down from the clouds
We're clouds.
into the ground, or an ocean, or a river, a stream, or pretty much any body of water on Earth. Then, when it gets hot,
We're the sun.
the water evaporates back up into the clouds.
We're clouds. Again.
Speaking of clouds, let's rise into the atmosphere.
The atmosphere is mostly made of oxygen and nitrogen.
Hi.
And this is yucca.
Yucca! And this is a human.
First, the plant breathes in CO2,
Oh,
carbon dioxide,
ouchie.
and out oxygen.
No ouchie.
And humans breathe in oxygen, don't take me away, and out carbon dioxide, CO2.
And this cycle goes on and on and on and on, and you get the idea. Now let's crash into the geosphere.
The geosphere is what we're standing on right now. The crust, mantle, and core. Remember, the geosphere is only made of non-living things.
Whoa, 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 whoa. We've got a whole list of things that prove that the geosphere is alive.
First of all, decomposition. When an animal dies, small decomposers tear away bits of flesh. And after a while, they become part of the soil. And plants grow through that very nutritious soil.
Back into the biosphere. This is an example how all the spheres are connected. The biosphere needs to drink the hydrosphere and breathe the atmosphere to survive.
Another example is minerals. We need minerals in our body. For example, we need salt in our hearts. Hey guys, I'm a mineral. Wrong scene. We need salt in our hearts, or else it wouldn't beat. And we need iron in our bloods, because. And our final example is stardust. You know how we're all made of stardust?
Twinkle, twinkle, little star.
If we're all made of stardust and stardust is alive, that would make everything alive.
How I wonder what you are. Did you know that the Earth is made up of living systems?
And all the systems are connected?
For example, look at this oak tree and its baby acorn. We're connected to all the spheres. One, we're connected to the biosphere because everything living is in the biosphere.
We're connected to the atmosphere because we breathe in carbon dioxide and out oxygen. And the humans breathe in oxygen and out carbon dioxide for us to breathe in and out and in and out.
That's enough. We're connected to the hydrosphere because, whoa! The rain gives us water. Yummy.
the geosphere because our roots are down deep into the soil part of the geosphere. And eventually my baby will fall and become her own oak tree thanks to gravity.
Yo, I'm gravity, and I'm gonna make you become part of the atmosphere.
Oh, no, Mom. I need you. It's okay. You'll become your own oak tree by yourself. No. And now my baby is part of the geosphere and will become her own oak tree. I'm time, and 100 years later, this baby grew up to my trusty friend, the
Hydrosphere. I'm the hydrosphere, and I gave this baby all the water she needs to grow up and become a big, strong oak tree.
And my other trusty friend, the
Atmosphere. I'm the atmosphere. I gave this baby all the CO2 she needs. And now, I have grown up to be my own oak tree. And I have my own baby acorns now. And this cycle continues forever and ever and ever and ever and ever and ever and ever and, well, you get it. But even if a human cuts you down, it still happens. No!
I'm my own oak tree.
Fun fact, did you know that we're related to every acorn, oak tree, Fourthito, oxygen molecule, water droplet, and we're even related to Big Rock! And we're all related through Stardust! We are minerals. We make up milk. No, rocks! Minerals make up rocks like a cake. The eggs batter in sugar, except it's minerals, minerals, and minerals. That's one cake I would not want to eat. And there are 3 types of rocks. The first one is igneous. Igneous rocks are made of cooled magma. When lava spurts out of a volcano, it cools down, and that's an igneous rock. But there are 2 types of igneous rocks. Hi, I'm an extrusive igneous rock. How an extrusive igneous rock is formed is when lava sprays out of a volcano, and on the Earth's surface, it cools over a long period of time. And now intrusive.
Hi, I'm an intrusive igneous rock. I'm formed when magma cools inside of a volcano, forming an intrusive igneous rock.
And the next rock is, drum roll please,
Sedimentary. Sedimentary rocks are formed when sediments compact on the seafloor. Sediments can be dead animals or plants or even just dirt.
But remember, in order to make a sedimentary rock, we need pressure and time. Hi, Grandpa Joe. Would you help us out with this? Okay. And that's how you make a sedimentary rock. But don't forget, they're the weakest, so really don't hit them. Hey, come here. Ow, that hurts. Jeez. Rough much. And the next rock is metamorphic. How a metamorphic rock is formed is when bits of rocks, like igneous and sedimentary, compact with heat and pressure. Hi, I'm heat. Yo, I'm pressure. Wait, we need Grandpa Joe for this. Of course. Get out here, time. Grandpa Joe, would you help us out with this? Okay. And that's how you make a metamorphic rock. And those are the 3 types of rocks. Have you ever heard of fossils? Well, there are 4 types of fossils. The first type of fossil is a full body fossil. How a full body fossil is formed is when dinosaurs die, in this case they're fighting. It's getting heated in here. And then they kill each other. After that, their bodies get washed into bodies of water, and over a long period of time, sediments compact on top of them. I'm talking about a long period of time. After that, there's wind, there's snow, there's rain, and there's sun. And paleontologists come and dig them up. Dig. Oh my god, a fossil! Yeah, but it's only the bones. But it's his full body. Well, yeah. It's still cool. Anyway, the second type of fossil is trace fossils. Trace fossils are the traces that animals leave behind. Like footprints or poo or their eggs. In this case, the T-Rex is going to do a footprint for me. And the T-Rex's footprint is like big, guys. Like seriously. Like look how big this is.
traces of the footprint. And that's trace missing. The next one is
Resin fossil. A resin fossil is formed as small organisms get stuck in sap and stays there preserved for millions of years. We're gonna need time to help us. Can you speed this up 100 million years, please? 100 million years later. Millions of years later, scientists will find it and take it back to the lab to study it.
remember. Scientists also use resin fossils to extract their DNA and use it to make dinosaurs. That is 100% true.
No, it's not.
The next kind of fossil is a mold fossil. A mold fossil is when a dinosaur dies on a rock.
Keep in mind that it can be a different animal or a plant.
And then over millions of years, we're going to need time for this.
Time?
Can you speed this up? 60 million years.
Okay. Bing.
Over time, the animal has eroded off the rock, and now it has left the exact imprint of the shape and size.
Ooh, an imprint.
Paleontologists find it and bring it back to their lab. Then use it as a mold to find the exact shape and size of the animal.
And those are the 4 types of fossils.
But we got some facts for you guys, like don't leave yet.
So, scientists use fossils to determine how old a rock is. Let's just say we have a sedimentary rock. The highest layer is always the newest, and the lowest layer is always the oldest. Scientists use fossils to predict the future. But what's a paleontologist?
A paleontologist is a scientist that studies fossils or digs them up.
Fossils, fossils, animals that leave bones, sediments that turn to stone. Fossils, fossils, animals that leave their bones, sediments that turn to stone.
Welcome to Topanga's next Top Rock or Mineral. I am your host, Miss Jen, and here at Manzanita, we get something called a nature name. Does anybody know what nature name means in the audience? Okay, so every semester, we have a topic, and we pull something from that topic out of the hat, and that is our nature name. And we spend the semester researching that nature name. And we put that research into our POU. And because we have been studying the earth, rocks, and minerals, our nature names were rocks and minerals. And thanks to you, over the semester, they researched that rock or mineral. And today, now, after weeks, months of research and waiting, it is time to determine who is Topanga's next top rock or mineral. Put your hands together for these rocks and minerals. And we have a lovely judge, the impartial, not related to any of them, Miss Gabrielle. Let's give her a round of applause. We are looking at who has the most research, who has the most interesting and relevant facts, and who can embody their rock or mineral and bring it to life. Because that's what Fourthitos do. They embody their learning into plays. So without further ado, let's find out who is Topanga's next top rock or mineral. Dun, dun, dun. Yeah, let's give them another round of applause. Metamorphic rock we found right out here on a canyon day. Check it out. You can tell it's lava because of the bubbles. Now, rocks, minerals. Thank you. You will say, what is your name? Whether you are a rock or mineral, and which type of rock or mineral you are. Dun, dun, dun.
Hi, I'm hematite and I'm a mineral. Hi, I'm mica and I'm a mineral. I'm calcite and I'm a mineral. Hi, I'm schist and I am a rock and I'm metamorphic. Hi, I'm rhyolite and I'm a rock, an igneous extrusive rock. Don't cross me.
Hi, I'm salt and I'm a mineral. Sesame Sandstone. You all knew that because I'm the best.
Ooh, the competition is hot here in Topanga's. Next stop, our mineral. Let's give them another round of applause. Next up, we have the minerals. How were you formed? Dun dun dun.
How I'm formed is when iron cools. Pick me. I am formed from convergent boundary plates crashing into each other. Pick me.
I'm formed when magma gets spurt out of a volcano and dries. Pick me. I am formed when the water that a salt deposit is located dries up and leaves salt.
I am formed by the fast cooling of lava on the Earth's surface. I am formed when lava or magma spurts out of a volcano and cools on the surface. I am formed when magma spurts on a volcano and it crystallizes as it cools.
I am formed on the bottom of the ocean when sediments compact. But you all knew that because I'm the best, as I said.
Ooh, the competition is getting super hot. Let's give them another round of applause. Our next question. Rocks, minerals, are you ready?
Yeah.
What do you look like? And if you know, what is your color and or streak? Dun dun dun.
Hi again. So, what I look like is I'm black and shiny. The prettiest mineral. I can be shiny and black and brown. And my streak is white.
I'm a white rock. A white rock, and my streak is white.
I'm a light gray rock, but sometimes it can be golden and dirty. Pick me, I guess. I'm a white and dark rock, and my streak is white. I don't know why they don't use me for jewelry.
I can be gray, bluish gray, blue, yellow, or pink. I have a vitreous or glossy luster. Sometimes I have a dull, earthy luster. And my streak is white, as you can see. I basically look like this. I can be smooth or bumpy. And my streak is brown. This is my streak. Hey again, pick me. My streak is white, as you can see. And I'm transparent, and I can be lots of different colors. And I'm the prettiest. I can be a light gray, a white, or a very light beige. I could have a pearly or dull luster. And I'm rough and sandy.
I look like sand glued together, and my streak is sand.
All right, we actually had a whole cool scene about the properties of rocks and minerals that we had to cut today. Does anybody want to share what is the difference between color and streak and a sight?
So the color of a rock or mineral is the color you see on the outside. And a streak is when a paleontologist takes a rock and scratches it on a hard surface. The powder that is left behind is the mineral streak, or true color.
Excellent, thank you. And decide to remember it's a petrologist. Now, next up, can we give them a round of applause? The competition is heating up on Topanga's next top rock or mineral. Now, rocks and minerals, where is one place all of us are found?
Topanga!
But our next question is, where else are you found? And if you know, how are you mined and what are the consequences of that? Dun dun dun!
Where I'm found is mainly in the USA along the Lake Superior, which makes me superior. And how I'm mined is when mining people use a huge magnet. And yeah.
I am found on the east coast of the US of A. I'm found on the bottom of maybe a road of mountains you can find me, and in tectonic plates, and I'm hey, you're
I'm mostly found
I destroy your landforms, and I do wildfires. Don't cross. I have found near or in salt lakes and in the ocean.
I am found in South America in the Andes Mountains, by the way, that's where I got my name. And apparently in Minecraft you can mine me with any pickaxe. Wait. I am found in the East African Rift Valley and in many other places. I am mined with the open pit mining method and taken to nearby plants. Well, I'm mined by the open pit method, and to get deeper and bigger pockets of quartz, they use explosives, and I can be found in Joshua Tree and I am mined by block mining. Block mining has no slavery involved, and block mining can cause sinkholes and contaminate water.
I'm found in many places, as you all knew that, because I'm the best. Well, one of my favorites is Zion, and I'm mined by small children at the beach.
Let's put our hands together for these minerals. Now, our next question will be, what are you on the Mohs hardness scale? But because we had to cut that scene, who can remind us what is the Mohs hardness scale? Quartz, what is it?
The Mohs hardness scale is how hard your mineral or rock is, and like diamond is the hardest it's its head.
And talc is the weakness. 101. Excellent. So, if you know, step forward for what you are on the Mohs hardness scale.
So, I have a 6 on the Mohs hardness scale.
Hello, and I'm a 3. I'm one of the softest minerals, and I'm a 3 on the Mohs hardness.
You were? Yeah, okay. I am a 4 to 5 on your Mohs hardness scale, and I'm not weak. Maybe.
I'm a 6 on the Mohs hardness scale. I'm a 2.5 on the Mohs hardness scale. But everything else about me is perfect.
I am rated a 7 on the Mohs hardness scale, and which means I'm strong.
I'm rated a 6.5 to 7 on the Mohs hardness scale, which means I could be just as strong as andesite.
I am rated a 6 to 7 on the Mohs hardness scale, which means, yeah, I'm as strong as you. But for me, I am a 7 on the Mohs hardness scale, so yeah, I can be as strong as you too.
I can be rated from 6 to 7 on the Mohs hardness scale, but as I said, you all knew that because I'm the best and everyone knows about me.
Woo, hard competition. Let's put our hands together again for these. Now we know humans can be very selfish members of the biosphere. They think everything's about them. So our next question is, how are you useful to humans?
I'm useful to humans because I help them pigment. Yeah, I'm the best. I'm useful to humans because I can be used for electrical insulation. I'm useful to humans because I am pretty, so I like go in the gardens for decorations.
Oh, well, I'm useful to humans because I fill in their streets. And, hopefully you all know what I'm useful for. I'm useful for preserving and seasoning food, and I'm also used in the chemical industry for tanning, dyeing, and bleaching. And you thought pigment was cool?
I am used for filling roadbeds, for tiles, for making statues because I am very strong. Like I said, so strong as you. I am used for making bricks because I am super strong, just as strong projects, but I do not do well as concrete because my high silica reacts. I'm absolutely useless.
Let's put our hands together again for these rocks and minerals. Yeah, rocks, minerals. This is your last chance to convince Miss Gabrielle that you are Topanga's next top rock or mineral. So any other facts you have, cool or scary, this is the time. Dun dun dun.
So, hematite comes from the Greek word for blood. I'm also the prettiest mineral here.
No, you're not.
No. You're very much not the prettiest mineral here. And, there can be, calcite can be any color of the rainbow except, any color of the rainbow. And purple calcite is the rarest color of calcite.
Schist can explode, causing abnormal growth of plants. And yeah, you better watch out. And I can have little gems in me. And I can also have little pieces of magnetic thingies in me.
Well, I am luster, and remember, I need wildfire, so pick me or else you'll stick with one eye open. Well, first of all, I want to say, hematite, your fact is going to scare the points right away from you. And then, I in nature, am found as halite or rock salt.
I am the second most common rock on Earth's crust after basalt. And and searching up on the internet how to mine andesite or how does mining andesite affect the environment doesn't work.
I am the most common rock found on the Earth's crust. Yeah, after andesite.
I'm the second most popular mineral on the Earth's crust. I'm the prettiest. And yellow is the rarest color. Pick me, I'm the prettiest. I'm not magnetic and I'm fractured.
When you search up sesame sandstone on the internet, do you know what pops up? Anyone? No? Topanga Canyon hippies.
Sesame Sandstone. They are about to change out of their costumes, so if you want to get a picture, this is your moment. And put your hands together one last time for Topanga's next
Thank everyone for being here today. Thank you very much.
And now, for seamless transitions, they are going to change out of their nature name costume and weigh it down as we as the Santa Ana's visit us often. And we are going to give Miss Gabrielle a moment to tally up the score for who is Topanga's next top rock or mineral.
It's me. It's gonna be me. It's gonna be the winner because I am the winner. I'm gonna be the winner because everyone knows about me.
Miss Gabrielle, are you ready?
I'm ready.
Please speak into the rock.
It was close. It was close. Am I just calling out the winner?
Go for it.
Okay. The winner is this mineral, I believe is a mineral. This mineral was extremely knowledgeable and embodied their mineral quite well. The winner is andesite.
What would you like to say?
I would like to say yet again that searching up how to mine andesite and how does mining andesite affect the environment doesn't work because one, college documents come up, and two, Minecraft comes up. And I don't want to have anything to do with any of them.
Let's put our hands together for these rocks I want to remind you that our next scene is the 4 types of weathering.
Okay.
The next one is root wedging. Root wedging is when an animal burrows in the crack of a rock, or a plant grows in the crack of a rock. Bombs away! And in this case, an oak tree. Oh, shoot. The oak tree is getting bigger and bigger, and then it splits open the rock, and the rock cracks open, and it's weathery. Next is abrasion. Abrasion is when us rocks and us sediment band together. World War 23! And then they get weared away. This is all your fault! And then they get weathered away by wind, rain, and sun. Here comes the sun. Do-do-do-do. Here comes the sun, and that's a frost wedging. Speaking of frost wedging, or a rock. And we got a crack, but that doesn't matter. Just don't pay attention to that. And nothing will ever break us apart. Well, hi, I'm Water, and I'm looking for best friends. You two seem to do the job. No! I'm Coolness again, and I'm Frozen / Coolness again, and I'm gonna freeze this water in between this rock. Let it go! Let it go! Can't hold it back anymore! Oh no, I'm expanding! Crack! Oh, this is all your fault, Water! And then it gets weathered away. And those are the 4 types of physical weathering. And that's one of the ways how the earth reshapes itself. This is the earth story as a fairy tale. And every fairy tale has to have a villain. Us humans, we're the villains. Yes, humans are the villains. Whoa, whoa, whoa! Slow your roll! At least we're trying to help the earth. We cause climate change. Oh, sure! You can't just going around saying that. Yeah, you can't go around saying that we're the villains and we're the heroes. Climate change is climate change affects all 4 spheres, which make up the earth, which affects the earth and ourselves. Give us one good reason. Forest fires. We're a forest! And I'm smoking. Don't smoke, it's gonna make a forest fire. Whatever. I'm on fire! I'm on fire! You're listening to the show! Okay, that was a pretty good reason. Give us a lot more. The sea level rising. Isn't it just a beautiful day on our balcony? Yeah, we have such a good view of the ocean. It's so tiny. It's probably low tide. Oh, it's getting bigger! It's getting bigger! Flood your house, flood your home. Now you shall swim alone. And because of this, animals and humans can die. And then, like when humans' houses get flooded, they can't live there anymore and they die. Same with animals. Oh my God, my house is all ruined from the water! I'd rather be at Manzanita where there's a drought. There's no water to ruin my outfit. Ah! See? Oh, no pun intended. We're the heroes. No, we're the villains. We're the heroes. Well, I think it's the heroes, but why can't we be both? Yeah, think about it this way. Are villains the villains if they don't have a choice? That was deep, huh? Really deep, bro. We still think it's the heroes. No, it's the villains. Bro, I think it's both. Do you know what fossil fuels are? No. What are fossil fuels? Fossil fuels are prehistoric plants and animals that have died and been buried under the earth and decayed, such as oils and coal. Wait, does that mean I'm about to pump dead dinosaurs into my car? Yeah, pretty much. So I'm gonna keep doing it. Looks like a tank's full. Vroom vroom! Dino-mobile! Fossil fuels can also be from wildfires, decaying leaves, garbage, and farting and burping cattle.
Get the gas masks!
Cars are also part of the problem. They create CO2.
Wait, the dynamobile is bad?
Yep.
Oh, vroom, vroom. Huh.
But wait, if Santa drives a sleigh, how does he not produce CO2 emissions? The spirit of Christmas has no CO2 emissions.
Ho, 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 ho. I'm Santa.
Wow, he really does need to cut down on the cookies. Yeah, he does.
You two don't get any presents this year. Now, what would you like for Christmas?
I want to know why humans burn CO2.
Well, we burn CO2 because CO2 makes energy, and we need energy. So, for example, light. And not just the light in the sky. We need light from light bulbs, which need energy, and energy is made of CO2. Another reason is because we have to get places in transportation.
Vroom vroom, the dynamobile makes a turn!
I mean, my reindeer don't fart out CO2 because I only feed them candy canes.
If I only eat candy canes, will I not fart out CO2?
No, don't just eat candy canes. You're gonna end up like me. You're on the naughty list.
No!
And the third reason we need it is because we need to cook our food. I mean, how could I survive without Mrs. Claus or sugar cookies?
Eat candy canes, top of the naughty list.
No! Now, if you'll excuse me, I have to go. On Dasher, on Dixon, on Prancer, on Vixen, on Comet, on Cupid, on Snowcone, and Rudolph on the foggy nights. Ho, ho, ho! Merry Christmas!
Miley, why is climate change happening now if humans have been on this earth for 100,000 years?
Well, we're gonna need time for this. Time! Yeesh. Hi, Time. Can you bring us back 100,000 years, please?
100,000 years in the past. Alakazam!
Wow! Those are our ancestors, the ancient humans, and they seem to have just discovered fire. You see, scientists believe that humans weren't humans until they discovered fire.
But why isn't the climate changing now if humans have been in the earth? Why isn't the climate changing now if fire produces CO2?
Well, because we weren't producing enough CO2 for the climate to change.
And we were in balance with Mother Nature, because even if they killed animals like me, they would use every part of me. And we were in balance with Mama Earth.
But why did humans get out of balance with Mother Nature?
Well, Time!
Yes.
Hi, Time. Can you bring us in the future 90,000 years, please?
Okay. Alakazam!
Whoa! You see, this is when humans discovered farming.
But humans ate animals back then. How does this make a difference?
Well, humans got bonked on the head. And forgot who they were. They thought that they needed more cows and that they were above Mother Nature instead of with Mother Nature.
I have a lot of money in my pocket, so I can buy more cows, get more money, and then buy more land and more cows and get more money, and over and over and over again. I want you, and you.
And then humans were off balance with Mother Nature.
I don't want to see this. Can we go home?
Of course. Time!
Yes.
Hi, Time. Can you bring us in the future 10,000 years, please?
Okay. Alakazam!
Whoa!
An average American produces 4,400 pounds of CO2 a year. That's 8 fat hippos. Family or person?
A single person.
No!
This is okay because we can reduce.
I know a way we can carpool or use bikes instead of a single car per person.
Exactly.
And we can use electric cars instead of gas cars. And we can use public transportation.
I'm so proud of you. And we can use windmills and solar panels.
I am relieved that humans are waking up and discovering that they are part of nature, not above it. The reason I am here is probably because my parents realized that they were part of nature, not above it.
See, we are the heroes. Well, if we're the heroes, then why is climate change still happening, and why haven't those things been done?
Hold up, guys. died, but the Earth went on.
Yeah, sort of like the Ice Age. The Earth went on after that.
So does that mean eventually the sun will get so big that it will engulf all the planets, including Earth, like Mercury,
Yum, yum, yum.
Venus,
Yum, yum, yum.
Earth?
Yum, yum, yum. Someday, the sun will become so big it'll become a red giant, and it'll engulf all of the planets.
And the Earth will end just as it began, as an exploding star.
And just as we came from Stardust, we return to Stardust.
Sing!